So the next trick is to add some synthetic random error to our idealized model for the Y data to create some artificial data, some artificial data with some realistic looking noise or some realistic looking error. And we have some choices about how that error should look. Mainly, if we're using the rnorm function, we care about the standard deviation of that error. We're going to be adding what comes back from rnorm to our data in order to add that noise to the data. Now, what rnorm is a random number generator for a normal distribution, which means that it'll select random numbers, but if you select enough numbers, those numbers that you get will reflect a normal distribution. And in order to define that normal distribution, you have to tell it what the mean and the standard deviation are. So one approach to this is to say, well, I'm going to be adding this to my existing model, so I should have a mean of 0 because I just want to add noise above or below my model. I don't want to add any sort of systematic shift or bias in the data. So I want the mean to be 0, and I just want a random distribution on either side of that mean. So a normal distribution around 0 will have some positive and negative values. So if we go back to the script, we can say, well, our Y data is going to be equal to our f of x plus a vector of values created by rnorm. Okay, so how do we use this rnorm? I'm going to do a help on rnorm. Rnorm is part of the norm family, a series of tools for dealing with normal distributions, and this is the random number generator. And it takes 3 main arguments. It needs an n, and that just says how many random numbers do you need, or how long should the vector be that I return. Then you have the arguments mean and standard deviation, telling it what are the characteristics of the distribution you want to sample from. So in this case, my length needs to be the same length as f of x. I can't just put a 1 here. It'll just recycle that one random number, and it'll shift all of my points by the same amount. I need to tell it, well, how long is this vector? Because I need as many random numbers to add to this as there are in that vector. Well, there's a function for doing that called length. You can find out the length of a vector with the length function. So I'm going to say that the number of points that I need as an argument is equal to whatever's returned by the length function of f of x. Then, as I mentioned, with this particular method, we want the mean to be 0 because we're going to be adding this to f of x, and we want to add variation on either side of f of x. We don't want to add bias to f of x. So we're going to leave our mean at 0. Now, our standard deviation then can be a choice that we make based on the nature of the noise we expect to have in our measurements. So if you have less certainty in that ability to make that measurement, you might use a larger value. If you have more certainty, you might use a smaller value. So just to demonstrate, I'm going to start with a value of 2. Okay, let's go ahead and run that. Now we can see what y looks like. And again, y is going to have 20 values that have all been shifted a little bit. But, maybe we want to see how they've shifted. So this will let us introduce how to start layering plots, how to make multiple plots on the same axes in R. It's pretty straightforward. Once you've created a plot, every time you call plotting functions after that, unless it specifically is starting a new plot, is going to keep going on this old plot. So if you want to add another plot to the existing axes, we can use the points function. And the points is specifically for plotting a scatter plot with individual points. Again, our x variable is still going to be our independent values for x, our independent variable values for x. But now our y is going to be these new y values we've created, that is our actual artificial observations for y. And we probably want to make this a different color of some kind so you can see the difference between the original plot. So let's make this orange, and we can specify the call or color argument. And there's different ways to specify colors, but one thing it'll understand are certain named colors, and orange is one of those. So let's run this. And you can see on our plot, it has added some orange points on top of our original black points. And you can see how random noise has been introduced around our original model as indicated by these orange points. Sometimes it's closer, sometimes it's far away. It looks like this is pretty close to 0 right here, what it selected from R normal. So that's one way to do it. If you want to get clever, you might recognize that, well, what I could do here is I'm just adding this to f of x. I could also make f of x my mean of my R norm. And I would get the same result, because I'm saying, well, the f of x values that I have are my mean, and I need to generate a random number for each one of those, with that being the mean and the standard deviation being 2. This should do the exact same thing. Of course, it's going to look a little bit different every time you run this script, because you'll have different random numbers. That's the source of the iterations we're eventually going to be doing with this. But that should, you can run it several times to convince yourself that it looks a little bit different every time, and that might give you a feel for how this Monte Carlo process works, because each one of these is a realization of the error.